Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had started discussion about the mole concept. Today, we will learn the mole concept in details. So, we had discussed that in the SI system, mole is one of the 7 base units. When we were learning about all the SI units, then also we had discussed about the mole. This is the unit for the amount of substance. So, mole is one of the 7 base units which was added to this list a bit later than the other units. So, why was this unit needed? The fact was that atoms and molecules are very small and minute particles. So, even if we take a very small amount of any substance, let's say we are taking very small amount of carbon, then if we want to find out the number of atoms in it, then the atoms are such small particles that even in very small amount of a sample, there will be very large number of these atoms or very large number of molecules. So, to express these number of molecules or these number of atoms, we need to have some unit which is specific for this range of particles. So, and it is also very impractical to always determine the amount of substances in terms of kg, gram or in the units of volume. So, we needed some unit which would easily express the amount of substance present in these chemical compounds. So, this was the utility of adding mole to the list of the SI units. So, now again, like the atomic mass and molecular mass, the definition of mole is also very relative. How? So, the definition of mole says 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 grams of carbon-12. If you remember the definition of relative atomic mass, there we were relating the atomic mass of other atoms in terms of carbon-12. So, since carbon-12 was considered as the base atom or the base element, so the mole was also defined with respect to carbon-12. So, let's say carbon-12, the atomic mass of carbon-12 is 12 AMU, okay. So, atomic mass of carbon-12 is equal to 12 AMU. Now, if we take 12 grams of carbon-12, there will be a certain number of atoms present in 12 grams of carbon-12. This number of particles were termed as 1 mole. So, 1 mole is the amount of a substance that contains the same number of particles or entities as there are atoms in exactly 12 grams of carbon-12. So, if 12 grams of carbon-12 contains X atoms, the amount of any substance which contains X particles, this will be called 1 mole, okay. Now, these particles can be of different types. They can be atoms for elements such as, let's say, carbon or sulfur or some metal. For that case, we can say atoms as these particles. Particles can also be molecules in terms of compounds such as, say, water or carbon dioxide. For these cases, the mole will represent the number of molecules. It can also be ions or even subatomic particles like electron, proton, neutron, etc. Okay. So, this was the definition of mole. Now, what is the number of atoms that we are talking about? So, what is the number of atoms which is present in 12 grams of carbon 12? So, Avogadro said that 1 mole represents 6.022 into 10 to the power 23 particles. Okay. So, this number, this specific number was known as Avogadro's number. So, we can say that 12 grams of carbon 12 contains 6.022 into 10 to the power 23 atoms of carbon 12. Okay. So, 12 grams of carbon 12 contains 6.022 into 10 to the power 23 atoms of carbon 12. So, why this Avogadro's number is specifically this number? That we will study later, but before that we need to understand one thing. Till now we were expressing atomic mass or molecular mass in terms of AMU. So, atomic mass or molecular mass is expressed in AMU, that is the atomic mass unit. Okay. So, but we can say that mass of 1 mole of any substance or 6.022 into 10 to the power 23 particles of any substance is called molar mass or gram atomic mass. Okay. So, mass of 1 mole of any substance or 6.022 into 10 to the power 23 particles of any substance is called molar mass or gram atomic mass. So, if mass of 1 mole is molar mass or gram atomic mass, so if mass of 1 mole is called gram atomic mass, then number of moles is called the number of gram atoms. Okay. So, if anywhere in any question instead of mole they say gram atoms, then we have to understand that they are talking about moles. Okay. Now, why is it called gram atomic mass? Because molar mass is expressed in grams. Okay. We were discussing about the atomic mass or molecular mass in AMU scale, okay, in AMU unit, the atomic mass unit, but the unit of molar mass is grams. Okay. So, sometimes in the question it is given that the mass of any compound is grams per mole. Okay. When grams per mole is given, that means they are talking about the mass of 1 mole or the mass per mole of a substance. Okay. Now, we have seen what is 1 mole, we have seen what is molar mass and the unit of molar mass. Now, the question arises that we are saying this is the Avogadro's number, or these many particles when it is present in any amount of substance, then we call it 1 mole. But why this number? It was a very interesting calculation that Avogadro had observed. The calculation was, let's say, the mass of one atom. Mass of one atom is atomic mass, we know, which is A, AMU. Okay. Now, we know that 1 AMU is equal to 1.66 into 10 to the power minus 24 grams. Okay. So, AMU will be A into 1.66 into 10 to the power minus 24 grams, right? Now, so mass of one atom is equal to A into 1.66 into 10 to the power minus 24 grams. So, mass of 6.022 into 10 to the power 23 atoms will be equal to A into 1.66 into 10 to the power minus 24 into 6.022 into 10 to the power 23 grams. Okay. Now, very interestingly, when we multiply this with this, it comes as A into 9.99652 into 10 to the power minus 24 into 10 to the power 23. So, this is 10 to the power minus 1 grams. Now, if we arrange this in a proper way, then it comes as A into 0.999652 grams. Now, see, this number is almost equal to 1, right? So, when we multiply this number with this number, that is 1 AMU in grams, and if we multiply this with Avogadro's number, then we get 1. So, till now, what we were expressing in AMU, the atomic mass of any atom, now the molar mass, that is the mass of these many atoms, come to the same number. The value of atomic mass and the value of molar mass becomes same, just we can express it in grams now. So, this was the reason why these many particles are considered to be 1 mole, so that the calculations also become easy and we can now handle it in terms of grams, which is known to us. This Avogadro's number, this number is expressed as Na, okay, Avogadro's number. So, this is written as Na. Now, there are certain formulas related to the mole concept, okay. So, molar mass or gram atomic mass is equal to the mass of Na atoms, okay, which can be written as atomic mass expressed in grams, okay. Similarly, for a molecule, molar mass or gram molecular mass equal to mass of Na molecules, or we can say molecular mass expressed in grams. Okay. Now, so let's say that atomic mass or molecular mass of a substance is equal to m. Okay. Now, if atomic mass or molecular mass of a substance is m, so when we represent this in terms of gram, this becomes the molar mass, right? So, m grams is the mass of 1 mole. Okay. So, 1 gram is the mass of 1 by m mole. So, for example, we are given with a random weight of a substance. Okay. Let's say we have been given with 10 grams of a substance or 20 grams of a substance, and we have to find the number of moles in it. How will we do that? Let's say we are given with x grams of a sample. So, x gram is the mass of x by m moles by unitary method. Okay. So, we can say that number of moles, which is written as small n, is equal to given mass of a substance in grams divided by molar mass in grams. This is one formula. Okay. Also, we can say that 6.023 into 10 to the power 23 particles is equal to 1 mole. So, if we are given with 1 particle is 1 by Na, this thing is Na, right? So, 1 by Na moles. So, if we are given with Y particles, we can say Y by Na moles. So, number of moles is also equal to given number of particles divided by Avogadro's number. Okay, this is another formula. So, we will learn about the other formulas regarding mole concept, and we will correlate them and do some numericals in the next lecture. Thank you.